Okay, so now we've got some exam questions on a regression analysis. So it says the data in the table below shows us the actual temperatures and the apparent temperatures recorded at a weather station. A scatter plot of the data is shown. The data will be used to investigate the association between apparent temperature and actual. So you can see here, I can already see that this is response variable and this is the explanatory variable. So be careful there. When now you look at the table of values here, they've actually listed the response one first. So just be careful when you're entering that, make sure you're doing it the right way. So it says use the scatter plot to describe the association between apparent temperature and actual temperature in terms of strength, direction, and form. So I've actually been given the R squared there. So I don't really need to. I could just do the square root of R squared if I liked, which was 0.92, I think it was. 7, sorry. So I could just, do the square root of 0.97. So it ends up being 0.98. So I know that it's a strong, that's me saying the strength. It's a strong, positive, and we're just going to say it looks linear. So there you go. I've used the scatter plot and I've described it. I'll get the 1 mark for that. Now it says determine the least squares equation. So you've got to work that out. Now you've been given the data, so you're probably best to enter the data in. Now it says to 2 significant figures. So here your best bet is to type it in. So I've got actual temperature. So I would type that list in. So I've done that one. And then we've got apparent temperature. So I called it this. Apparent temp. And enter. So there's the 2 lists. I want to get the least squares equation, so I'm going to do it here. So menu, stat calculation, a plus bx. So actual is the EV and apparent is the RV, and I click OK, and there I have my values. Now it said 2 significant figures, so if I look at A, it's negative 1.7. Okay, there's 2 significant figures. And for the B value, it's going to be 0.94. Okay, be careful with these. Sometimes you don't need to put the sign. I'm just going to fix that up. Sometimes you don't have to put the sign because they might have it outside the box. Just make sure you're looking carefully at what they have because it needs to be negative. So they don't have a negative outside the box, so I'll pop it in there. Now, it says to interpret the intercept of this equation. So if you go back to that thing, so we'd be writing the regression line intercept predicts the average value of apparent temperature to be negative 1.7 when the actual temperature is 0. Okay, so there's my thing. It said the coefficient of determination is 0.97. Interpret the coefficient of determination. So once again, you'd go I'm gonna do it brief. You can, we're not gonna write things, so I'm just gonna write how much. So it's 0.97. So I'm gonna say 97% of the variation in apparent temperature is explained by the variation in actual temperature. Okay, so as long as you've got that, you're good. Then they've given me the residual plot. So I'm just going to practice. Let's see if we got that. So if I draw a scatter plot of mine and I put in the regression line so that I can get a residual plot. There you go. Yep, that looks like what they got. So the residual plot can be used to test an assumption about the nature of the association between the two numerical variables. What is that assumption? What did I assume when I put that straight line in there? I assumed what? It was linear. So we assumed at the start when we did all the values, the assumption that it was linear. That's why we did a residual plot, because it says, does the residual plot support this assumption? We're going to say, yes, it does, as it shows no clear pattern. Okay, so in the residual plot, no pattern equals linear. Okay, and let's go. We'll just do these last few questions. This is a different thing. It just says, you've been given the scatter plot and the residual of life expectancy and HDI. Given this information, which one is not true? So here they've given you R squared. So we would be saying 87.5% of the variation is explained. So if you go down and you read this, it says 12.5 of the life expectancy is not explained. So that's actually true. So that's true. The square root, the correlation coefficient. So let's have a look. If we got given R squared, let's check that one. So 0.875. R would be 0.94. So that is true. That is true. On average, the life expectancy increases by 43 years for each 10 points. Now, this one's not true. When you see this wording here, I'm just going to show you. When you see this on average, something increases, that is talking about, the gradient. So it's talking about the B value. Though, if we look at our B value is 0.42, and they're saying if you increase it by 10, so times it by 10 instead of 1, what we normally do, it would be 4. But you can already see they're using the A value there. This is not true. That's the not true statement there. So I'm going to take that one and say it's not true. If you read the other ones, let's see that they're true. Ignoring outliers, the association between them is described as strong, positive, and linear. I would say that's true because the R value is strong. The dots seem to be going into a positive way. And this shows no pattern. So no pattern, which suggests it's linear, equals linear. So that one's good. And then using the least squares, the 75 is an example of interpolation. That is true because it's within my dots. So C is the wrong one. And then it says life expectancy in Australia was 81.8 years with a human development of 9.2. And it says use the line to predict the residual. So let's write this. So a residual is actual minus predicted. So it's your actual Y value. So Y value is life expectancy. So Australia actually had 81.8. And I'm going to use the equation to get its predicted. So 43.0 plus 0.422. And I have to times it by HDI, which they told me was 92.9. So then I can get the residual. So 81.8 minus, put the predicted one in a bracket, like what I'm doing. Otherwise, your calculator might, what was the 92.9? Oops. Okay, so I get a residual of negative 0.4038. So my answer is B.